Close your eyes. Imagine for a moment that we are on a ship. This is not an ordinary vessel that sails upon the water, but a vessel that sails through time itself. We glide silently backwards, past the years and decades we know, past the centuries, watching history rewind like a film in reverse. Our journey takes us much, much further back, to a time before human memory, before the first cities, before even the great ice ages. The ship finally slows its monumental voyage and comes to a gentle stop. We have arrived. We are now 60 million years in the past, in an era scientists call the Paleocene. The air that greets us feels warm and thick on our skin, heavy with moisture, the scent of wet earth, strange sweet blossoms. The world outside our vessel looks both alien and strangely familiar, a planet teeming with life, but in forms we hardly recognize. We look towards the poles of the earth, but there is no glimmer of ice, no vast white sheets. With no polar ice, sea levels are much higher, warm oceans spilling over the land, creating shallow sunlit seas where new life flourishes. This is a world in recovery. Not long before our arrival, a great asteroid struck the Earth, ending the long reign of the dinosaurs, sending shockwaves and a planetary winter that wiped out nearly 3/4 of all life. But life is resilient. As we gaze upon a map of this 60-million-year-old Earth, we see the very ground beneath our feet is in a different place. The continents are not arranged in their familiar patterns. They drift across the planet's molten mantle, a dance billions of years in the making. At this moment, the world map is a work in progress. Africa, South America. Once joined, they have separated, but the gap is much narrower than today's Atlantic, close enough that life might cross, though the journey would be perilous. Europe is not a single landmass, but an archipelago, a scattered chain of large and small islands set in a warm, shallow sea. What will become the Alps and the Himalayas are still low hills or seabeds, yet to be pushed up by colliding continents. North America is recognizable but different, with a vast inland sea cutting through its center. Land bridges like Panama have not yet formed, isolating many animal populations. Perhaps the most dramatic journey is India, not yet attached to Asia, a massive island continent, like a colossal hot stone, sailing north across the Tethys Ocean, carrying unique plants and animals. Its collision with Asia is millions of years away, but when it comes, it will thrust up the Himalayan peaks and alter global climate patterns, one of Earth's great geological events. The rearrangement shifts ocean currents and global heat distribution. New seas and separations create barriers and corridors for migration. An animal once roaming freely might now be isolated on an island, forced to adapt or go extinct. Slow, relentless drift is the silent engine of evolution, shaping the destiny of life on Earth. The climate of this Paleocene world is profoundly different. It is a hothouse Earth with higher greenhouse gases trapping the sun's heat. Global average temperatures are significantly warmer. Warmth is distributed more evenly across the planet, so the equator to pole difference is smaller. There are no polar ice caps. Lands near the poles are free of permanent ice. Temperate and subtropical forests cloak high latitudes, a sight astonishing to us now. The sky is often hazy, a pale canvas filtered through a humid atmosphere. Rain is frequent, not a gentle drizzle but heavy sheets that drench dense forests and swell slow rivers. Thunderstorms can be spectacular and violent. Winters are mild, more like cool, wet seasons. Summers are long, warm, and humid, perfect for rampant plant growth. Tropical conditions extend far beyond the equator. Imagine lush forests in Antarctica and northern Canada. High-latitude forests face months of daylight in summer and darkness in winter, demanding special adaptations. Higher CO2 fuels rampant plant growth and makes oceans slightly more acidic, affecting shell builders. Seas are full of life, but the winners are those that adapt to these conditions. This warm, steamy, carbon-rich atmosphere shapes life from the tallest tree to the smallest sea creature. In a world without large grazing dinosaurs to clear plains, forests have conquered the land. From the equator to high latitudes, Earth is cloaked in thick green. These are not managed pine woods but wild, tangled, incredibly dense forests. Ferns, some as tall as trees, unfurl delicate fronds in deep shade. Palms flourish along warm shores, alongside towering broadleaf trees, ancestors of walnuts and sycamores, forming a vast interlocking canopy. Below, deep shade and still air rule. Life competes for precious rays. Enormous lianas hang like ropes. In canopy gaps, sunlight ignites a riot of fast-growing plants. The ground is strewn with strange fruits and large seeds, feeding small animals in the leaf litter. Flowers spread, adding color and drawing vital pollinators. Many plants are new lineages after the extinction, some familiar to botanists, many utterly alien, known from fossil leaves, pollen and seeds, a story of botanical experimentation. Along coasts and deltas, mangrove-like plants with stilt roots anchor in salty mud, nurseries for marine life and buffers against storms. In swamps and riverbanks, mosses, reeds and giant horsetails grow in profusion, roots submerged in slow waters. This world of green underpins the Paleocene food web. The most striking feature of Paleocene animals is the absence of giants. The colossal dinosaurs, the fearsome meat-eaters, the gigantic plant-eaters, are gone. Their disappearance leaves a profound void and an unprecedented opportunity for mammals. Once small and nocturnal, they now step into daylight and diversify at astonishing rates. Some are herbivores, feeding on leaves, fruits, and seeds of the new forests. Among them are early ancestors of horses, small, dog-sized, with multiple toes, perfect for soft forest floors. Others are insectivores, some become predators, hunting small animals. In the trees, early primates thrive. Ancestors of monkeys, apes, and humans. With grasping hands and feet and forward-facing eyes, they leap with agility through the canopy. Small and nimble, they feed on fruits, insects, and tender leaves. In them, we glimpse a distant reflection of ourselves. Birds, survivors of the extinction, fill the skies. Some are small and quick, flitting through dappled light. Others evolve into giant, flightless terror birds with huge, sharp beaks patrolling the forest floor. A fearsome reminder, the age of reptiles has given way not just to mammals, but to dinosaur descendants as well. It's a strange and fascinating time. Our journey to this moment is a crucial chapter of Earth's story. Seeds of modernity are planted, lineages expand. Opportunity fuels rapid evolution, a quiet genesis happening all around us. The warm, expansive oceans of the Paleocene are teeming with life, recovering and changing after the great extinction that also devastated the seas, wiping out mosasaurs, plesiosaurs, and ammonites. Sharks, veterans of multiple extinctions, patrol these waters. Vast schools of fish from modern groups shimmer in sunlit shallows. Coral reefs begin to recover, building new structures that host sponges, sea urchins, colorful fish, and countless crustaceans. Deeper, quieter seafloors teem with burrowing life, recycling nutrients. The base of the web, plankton and algae, floats near the surface, harnessing sunlight. A fascinating development. Strange mammals test the waters, the very earliest whales. They don't yet resemble today's giants. They are amphibious, four-legged, walking on land and hunting fish in rivers and estuaries. Over millions of years, descendants lose legs, develop flukes and blowholes, and become the largest animals ever to live. While giant marine reptiles vanish, crocodile-like champsosaurs thrive in rivers and swamps, ambushing fish and unwary land animals. Sea turtles glide much as they do today. These oceans mix ancient survivors with new innovators, a vibrant arena where the next chapter of marine evolution begins. It's a really exciting time beneath the waves. The Paleocene surface is not tranquil. Beneath the crust, inner fire breaks through. Volcanoes mark colliding and pulling plates. Spectacular eruptions loft ash and gases high into the atmosphere. Ash travels thousands of miles, settling as time-marking layers in rock. Rivers of lava burn through forests, creating vast black rock fields that will weather into fertile soils, eventually. Elsewhere, effusive eruptions well up through giant fissures for thousands of years, building immense layered plateaus. Volcanic CO2 and methane can trigger major warming events. Scientists link intense volcanism to Paleocene warmth and even hotter spikes. Our journey is made possible not by a machine, but by patient science. We lack photographs, but the Earth's rocks and fossils form an extraordinary library. Fossils reveal size, shape, and movement. Teeth, by form and wear, tell diets, tough plants, soft fruits, or flesh. Fossilized leaves and wood show species and structure. Pollen, preserved in lake and swamp mud, tracks forests through time via drilled cores. Foraminifera chemistry records seawater temperatures. Leaf shapes infer warmth and rainfall. Carbon isotopes reveal CO2. Paleomagnetism in cooling rocks fixes ancient latitudes and rotations. Millions of data points reconstruct paleo maps. So, it's really a giant detective story written in stone. Our journey to 60 million years ago ends, but we return with perspective. The Paleocene is not only strange animals and ancient forests, it's a lesson in resilience and change. We see a planet recovering from catastrophe, life's tenacity to radiate, diversify, and fill every niche. A hothouse Earth, high CO2, no polar ice. Rocks show climate's sensitivity to atmospheric composition, a real-world case of dramatic warming. By studying shifting ecosystems, migrations, and oceans, we gain vital insight for today. The past and present are linked. The same tectonics, same rules of evolution. Deep time fosters humility and wonder. As we open our eyes, we're back, seeing differently. Change is constant. Recovery is long. The ancient Earth has spoken. Listen, learn, understand. Well, let's hope we do.